I'm going to talk about dependency parsing as MRC-based span prediction. This article in 2022 by Peking University, the second university in China. And there are other interesting articles like this one, headed span-based projective dependency parsing, that are important. And of course, this is a negative sample. This is not similar to the other articles, but it's a very great article, K-best non-projective dependency trees. So higher order dependencies are only partially important. The article wants to focus and wants to emphasize on the fact that what we are doing in dependency parsing is not natural to the human brain. I think, for example, if we have a sentence, we should see how these subspans are related to each other. And so span should be the basic element, not the word. Because in dependency parsing, we usually say what is the relationship between two words. And for example, this is head and this is the dependent or modifier. But you know, it is more general. We can generalize this to say that what is the relationship between two spans. And each span is could be a subtree. And so a tree has a root. So the root of this has a relationship to a root of that. I mean, the span of this is related, but the span is represented by its root. So the proposed method constructs dependency trees by directly modeling span. In other words, subtree relation. So it consists of two modules. The text span proposal module, it proposes candidate spans, each of which represents a subtree in the dependency tree, and we know we represent it by root, start, and end. The other module is span linking. Now that we know what are the spans, we construct the links between them. So it's very beautiful. One span is used as a query. We can think about it just like, if you know reading comprehension, one span we can think about is used as a query to extract the text span or subtree it should be linked to. The proposed method has the following beautiful merit. It addresses the fundamental problem that edges in dependency tree should be constructed between subtrees. And so you see span is more natural. For example, here, this is one span, this is the total span, but we see that if we say that this is a subset of the bigger span, so if this span is a subset of a bigger span, then they are related. So they are related by cat. So if cat is the head of the smaller span, and love is the head of the bigger span, they are related by the object relation. And so as I said, the text span proposal module, it proposes eligible candidate text spans, each of which represents a subtree in the dependency tree. And the span linking module, which constructs links between the proposed spans to form the final dependency tree. We use machine reading comprehension as the backbone to formalize the span linking module. So one span is used as a query to extract this text span it should be linked to. Instead of saying, for example, what is the similarity between two spans, that is not a good idea. The idea in this paper is said that we think about as a query to find the answer. They notice that framework has a better result. and it's easier, of course. Examples of spans and links, I talked about it. So each span has a root, and we put root by the subscript. So these subscript are the root, and T is the span. So span of this is related to span of this. The span of this has root, and the span of love has root love, and so you see how they are related. So we list all of them, and we are learning that. How do we learn that? So we say, what is the maximum score of this tree? We compute the maximum score. We say that it is the span. As I said, we have two modules. First span and then the linking of them. So we are going to model these things. As you know, it's easy in deep learning to model these scores because we have done it in a machine reading comprehension. So because the start, it depends on the I and j, so we relate them by this function. This is the score of j given I, and the start is the root. It starts from the start. So we know that the score of span, we can write it as score of start, and score of n. And for example, all of them are similar. After giving it to the bird and creating some good representation, we can find the loss to be the half span, the left half span proposal module. Because it starts from start until the root. So this is the start, the score of that, and then we model the end similarly. It's just a function of xi and xj, and the similarly for n span. Now span. So how are we going to model the score of root, the score of start? They are similar. We use the representation for the token with index t, which is output by the bird, and we can model the score of wt. It is so score of wt given T is a softmax over all constituent tokens. And you see the details are in this paper, and we calculate the score of this span candidate T. I mean, T is in a subset of span candidates because there are many. After finding the spans, then we do the linking. So we need to know the score of the linking. And we can do for projective decoding and non-projective decoding. You know, for non-projective decoding, we use a maximum spanning tree, and they have used here as well. Because we cannot just use Eisner algorithm. Eisner is just for projective decoding.